Good morning and good afternoon, everyone. Welcome to DTN's Midwinter Weather Risk Assessment webinar. My name is Andrea Berg, and I am your host for today's session. I am joined today by our long-range meteorologists, Jeff Johnson, Nathan Hamlin, and Stephen Strum. I just wanted to go over a few housekeeping notes before we start today's session. We are recording today's session, and we will be sending out a link to this recording to everybody who registered for today's event within a few days. If you are experiencing any technical difficulties during the presentation, please use the chat feature, and I will hopefully be able to help you and troubleshoot any of those technical difficulties. We will have some time at the end of the presentation for any Q&A. So if you have any questions, please use the Q&A feature on the right-hand side of your screen, and you can then ask the questions and we will address them at the end of the presentation. So now I would like to introduce Jeff Johnson, who will go through the first part of our presentation. Jeff?
Thank you, Andrea, and welcome everybody. Appreciate you joining us for this update for the middle of the winter season. We do expect a little more winter to come, and we've had a bit of it already. Let's see, get going in the right direction here. But as Andrea mentioned, this presentation will be conducted by three of us. I'll start out the first part, pass it off to Nate, and then Steve, and all three of us do have quite a bit of experience in long range and seasonal weather forecasting. The topics we're going to be covering today, I'll be covering a review of what we've had here so far this winter and what is typical with La Nina, and then shift it off to Nate, who will try to cover all of the different pieces of data and information that we look at to try to put a forecast together. And then Steve will handle the last part, going through some of the impacts and specifics of the upcoming winter forecast. So first of all, a review of the past several months, highly influenced by the position of the jet stream. The map on the right shows a stronger than normal jet stream across the northern part of the country, with those yellow and orange shades indicating stronger wind speeds up at the jet stream level. And that jet stream position was caused by a weak to moderate La Nina, and it has been weakening here in recent weeks, but still remains a weak to moderate event. And that jet stream in that position caused the main storm track to be across primarily the U.S.-Canada border on the average. The early part of winter was abnormally mild, especially in November and into the first half of December, but then we started seeing some Arctic air intrusions begin to move in for the latter part of December up through the present time. Overall, precipitation across the country has been lower than average in many areas, but there were some exceptions, mainly for a month or so out on the west coast. And then we've seen a more active winter storm pattern develop in the middle part of December, and that more active pattern continues to this time. So one thing we like to look at in our forecast process is the location of the lower atmospheric polar vortex, and it often does break up into multiple centers, but generally where we do see the polar vortex, we do tend to have colder weather. During the month of November, we had a weaker polar vortex system that did take up residence over the eastern United States with higher pressure to the west. And then in December, that polar vortex retreated primarily into the western part of Canada, taking any cold air with it. And then so far during the first half of January, we've seen the polar vortex mainly located across Canada, but stretching out across that entire country, allowing more cold air to build up across Canada and work its way down into especially the northern part of the country. Now, reviewing what we've had in terms of temperature impact so far. The map on the bottom shows the November through January temperature departures, and overall, most of the country has been warmer than average. Canada has been cooler than average with that transition zone across the northern tier of states. Specifically, looking at the month by month breakdown, in November we had below normal temperatures in the east, primarily with that weaker polar vortex system in that area. And then for December, you can see how that cold retreated back toward western Canada, and it really warmed up across most of the United States. And then here, so far in January, we've seen an expansion of the cold air coming out of Canada, working its way down through the eastern half of the United States. So far, the heating conditions since the beginning of the heating season, warmer than average across the entire area, and we've had reduced heating degree days and a reduced heating demand so far this winter season on terms of the total. Now, those warmer than average temperatures have also had an impact on the Great Lakes ice coverage. This is important for you around the Great Lakes area that get a lot of lake effect snow. And this is a current map showing the ice coverage around the Great Lakes as of yesterday. And the ice coverage is indicated by the gray and blacker shades just across portions of the Great Lakes. The blue colors represent the temperatures of the water, so that would be all open water for the majority. And right now, only 14.9% of the Great Lakes are covered by ice. The graph on the right shows the typical percentage of ice coverage throughout the year with the red line, but the black line on the bottom shows how so far this year we have been running below the typical percentage of ice coverage. So generally, the bottom line is the Great Lakes are warmer and more open than they would be on this time of the year. So the threat for lake effect snow going forward is going to be ahead of what it's typically expected. Now, reviewing the precipitation amounts so far this winter season, on the bottom again is the November through January period, and the browner shades represent drier than normal conditions. So again, most of the country experiencing less than normal precipitation, the exception being in the Pacific Northwest across the US-Canada border. Most active months so far have been during the month of December, where some very heavy precipitation came into California and the west, as well as around the Great Lakes area, Northern Plains. It was a more active snow pattern. And then so far here during the month of January and including the forecast through the end of the month, it has been and will be more active in the northwestern areas, the southeast, southern Texas, and parts of the central plains. Now, season to date snowfall, the map on the left shows how much snow has fallen since the beginning of the season on October 1st. In general, the yellow shades would represent a foot or more of snow. So the main areas seeing that would be out in the western mountains as well as the far northern states. But also take note of the snow that has extended so far down through the mid-Atlantic states and the Appalachians back into the Kentucky and Tennessee region. The map on the right shows how that snow compares to normal. So the greens indicate more snow than normal. And again, that southern Appalachians region through the Tennessee Valley area. But also take note in the northeast, the yellow shades represent less than average snowfall so far, and above average in the far northern part of the upper Mississippi Valley, but parts of the eastern Great Lakes a little drier on the snow side so far. Now looking at individual monthly events for the month of November, snowfall map on the right, so you can see most of the snow was in the Great Lakes region and the northern part of the Northeast. And it was very mild, as you recall, during the month of November, especially in the western and central U.S. A little bit chillier air occurred in the southeast and east due to that weaker polar vortex that averaged its position there in the northeast U.S. Of note is that Several atmospheric river events impacted the northwestern part of the country into British Columbia, with some torrential rainfall and flash flooding, along with tropical storm force winds. During the middle part of November, there was a strong area of low pressure that impacted the northern plains and Great Lakes into the northeast, with some snow and strong winds, and also some cold air came in and did produce some heavier lake effect storms, snows. And then the rest of the country, however, experienced a drier than normal pattern for the bulk of the month. In December, we started to see things turn a lot more active in some unusual ways. We did have some very mild temperatures in the central and eastern United States, with the colder air retreating into the northwest part of the country. The map on the right shows areas that did receive snow during the month of December, and you can see areas that got the heavier amounts were in the Northeast, the upper Midwest, as well as through the Rockies. But we had a couple very unusual storm systems for that time of the year. It was actually a spring-like storm pattern that produced two very significant tornado outbreaks. One of them was on the 10th and the other on the 15th of December. And the two maps on the lower left show the severe weather reports from those 2 days. So on the 10th, we had those very destructive tornadoes that moved through parts of eastern Arkansas, through Tennessee and Kentucky, with quite a bit of damage, but also severe wind gusts that extended further north across Missouri, Illinois, and Indiana. And then on the 15th of December, the second map there on the bottom shows the tornado and severe weather reports. Tornadoes again in red, but we had quite an outbreak that did uh, produce damage as far to the north as southern Minnesota and Wisconsin. And what we had out of that particular system on the 15th was also some widespread damaging wind gusts. And I'll show you a larger view of this map in just a second, but those widespread winds occurred across the Central Plains into the upper Midwest region. But before looking at that, I want to also mention another significant event that occurred on December 30th. This was the Marshall, Colorado wildfire, and there were again widespread 60 to 100 mile an hour wind gusts that occurred across eastern Colorado with that event, and unfortunately uh, fanned a wildfire that spread through the city of Marshall. And otherwise, we did experience some winter storms, as I've mentioned earlier on the snowfall graphic, mainly in the northeastern part of the country, as well as in the upper Midwest. But just want to take one closer look here at these strong wind gusts that occurred on the 15th. All of those areas in orange and red were very strong wind gusts. The highest one was 107 miles per hour in Lamar, Colorado, but wind gusts in South Dakota up to 79, Nebraska 93, Missouri 90 mile an hour, and some of these were associated with a line of thunderstorms. Others were associated with strong winds behind the cold front, and there were also wildfires that did occur with those strong winds, especially in Colorado, Kansas, and into the Texas Panhandle region. So, two very major wind events that occurred, producing fires as well as severe weather. So then we come to January, and we have had generally mild temperatures confined more to the southern part of the country, with colder Arctic air starting to leak into the northern half of the country, especially. Several notable snow events on New Year's Day. A band of snow moved from Colorado to southern Michigan, with around 4 to 9 inches in the Midwest and plains, and over a foot in Colorado. And then on January 3rd, Tennessee region up into the mid-Atlantic, we had snow, and this was the infamous system that stranded traffic on I-95. and up to 10 to 15 inches of snow with that. And then just a few days later, another band of snow from Kentucky to New England with 6 to 14 inches and some heavy lake effect snows. And then more recently, last weekend, we had that large system that began in the upper Midwest with about 11 inches of snow in Iowa. You can see the map of snowfall from that storm. So one area of snow around the Iowa area, and then as it dropped south and recurved up through the Northeast, we had an ice storm that occurred in the Carolinas, heavy snow in the Appalachians up into New York, and then also four tornadoes across the state of Florida. Now, before going to the forecast section, I just wanted to review some statistical things that we tend to see with La Ninas. Generally, with snowfall, we tend to see enhanced snowfall across the northern part of the country. I'd say we're in a weak La Nina right now, so generally the middle graphic would represent enhanced snowfall in the northwestern, north central, and far northern parts of the Northeast. So La Ninas generally do give us more snow across the north, mainly due to that northern storm track. But also, organized La Ninas also have an impact on tornadoes, even during the winter, December, January, February on the left. This particular study shows that there's a greater frequency of tornadoes during those winter months, especially centered around the Arkansas, Mississippi, Western Tennessee, Southern Illinois region, kind of right in the heart of where we saw those major tornado outbreaks in December. So nothing too unusual that occurred, although it was pretty extreme, but we do tend to see winter tornadoes more active with La Ninas in those areas. And then also in the spring, March, April, May on the right, the red areas show a greater frequency of tornadoes when you have a La Nina during the spring season, and a pretty widespread area of enhanced frequency across much of the central and eastern United States. So as we go through the forecast, keep in mind that the La Ninas do tend to have an impact on severe weather that's quite notable. And just to bring it up to the forefront a little more, in 2008 and 2011, we had some pretty strong tornado outbreaks due to lingering La Ninas during the spring, and those years were well above the average number of tornadoes that has occurred over the last 15 or so years. 2020, we were a little bit below that average line for a total, but we are expecting a more active year this year due to the presence of that La Nina. So that's a rundown of what we've had so far this this winter and what we expect the impacts from La Nina to be. So now I'm going to hand it over to Nate, and he's been looking at a lot of different pieces of data and influences, and is going to try to paint the picture on the forecast for the upcoming few months. So take it away, Nate.
All right, thank you very much, Jeff, for that thorough review of what has happened so far and some of the background information that provides a lot of context for the forecast that we are about to deliver. Let's first take a look at some winter season, excuse me, influencers. And ENSO usually is the top influencer of the season, especially if it's strong one way or the other, El Nino or La Nina. Typically, 40% of the influence, it can vary based on strength. But we have pretty good skill at predicting that, and we have a pretty good idea of what they typically like to do. But we do have some other things that can sneak in there and provide differences. Things like the polar vortex, that could be almost 30% if it's strong, if it's too strong or too weak. We have fair skill predicting polar winters that have polar vortex disturbances or not having them. We're not as good at that as we are at ENSO predictions, but we're fair at that. But where it's a little bit harder to do from a seasonal standpoint are some of these sub-seasonal influences like the MJO, Madden-Julian oscillation that can have influences, significant influences for short time periods. And then, the recent trends, we have a pretty good, we're pretty good at looking out the window and seeing what happened and picking out what's important going forward as far as what we want to put in the forecast. So let's take a look at the main seasonal drivers. And the ENSO mode this time around is going to be La Nina. We're in it right now, and it's probably going to last all the way through the spring. And looking at the map on the right, you can see the sea surface temperature anomalies, and that area along the equator, the Pacific Ocean, west of South America, there's a lot of blues in there, especially east of the dateline. So what that indicates is that La Nina will last through the February, March, and April period. The other thing, a couple areas we'd like to look at away from that, the northern Pacific Ocean. So what you see there's a lot of warm water across the North Pacific, especially south of the Gulf of Alaska, with some cooler water closer to the west coast and up into the Gulf of Alaska itself. That's indicative of the cold phase of the Pacific Decadal Oscillation, or the PDO. And we also see a lot of warm water across the Atlantic Ocean. So what we like to do is look for years in the past that look a lot like this, and that can give us some clues as to what's coming in the next few months. Let's take a little focus on ENSO here. And here's forecast from modeling centers all across the world, all the way through the summertime and into the fall. And right now we're solidly into the La Nina camp, but every single model is showing a weakening of that, some a little bit more than others. By the time you get to April, the thick red line, the average, finally crosses out of the La Nina threshold of minus 0.5 degrees Celsius or cooler. And then by the time we get into the summer, we're closer to neutral. There are some models that linger La Nina a little bit longer, and then some others that want to charge towards El Nino. So there's a little bit of uncertainty by the time we get to the summer, but the model trends are pretty clear, and this event is going to weaken here over the next few months. So let's take a look at some analogs. So average weather conditions from previous years with the similar ocean temperature patterns that we showed you a little bit earlier. And these years that we've selected, weighted according to how good we think they are, how close they are here. And we have all the main features covered. So you see all the warmth in the Atlantic Ocean, and you see the coolness off the west coast of the US, and that warmth south of Alaska and the central Pacific Ocean. You also see the La Nina with the cooler than normal sea surface temperature. So this set of years has the large sea surface temperature pattern drivers covered pretty well. And here's our DTN analogs through the spring. So this is what they did. And you notice here as we get January through March, and then getting into April and June, you see we are weakening, crossing out of the La Nina threshold sometime during the spring towards neutral by June. So it fits pretty well with the model guidance that has been presented to us. Our jet stream analogs, not too dissimilar to what has happened so far, stronger than normal jet stream indicated by the yellow and orange colors across the northern part of the US, with weaker than normal jet stream winds across the Gulf of Mexico and the far southern part of the country. So what is part of what has happened with the jet stream will likely continue to happen through the rest of the winter season. Let's look more specifically at temperatures and precipitation from our analog choices. And here is February. So each one of these maps, on the left you see temperatures, on the right you see precipitation. Warmer temperatures have the warmer orange colors, and colder than normal temperatures have the cooler blue colors. And it is clear to see that the analogs favor below normal temperatures across the north central US, south central and western Canada, and the western part of the United States, with warmth across the East Coast. There will probably be some transition zone in between across the Midwest. And precipitation on the right, where the transition zone is, there's lots of green there. So usually we have those tight temperature gradients, there's a lot of precipitation near them. And this doesn't look like to be any exception. There's well above normal precipitation from the Arklatex region, the middle Mississippi Valley upwards towards the Great Lakes and into the Northeast. Below normal precipitation along the West Coast and across the far southern reaches of the US. For March, we see that cold retreat, all below normal temperatures basically across British Columbia and western part of the United States, with above normal temperatures across most of the central and eastern part of the country. Precipitation on the right shows you that active weather will occur near the west coast and also across the Arklatex region, lower Mississippi Valley, and into parts of the south. Below normal precipitation from the Great Lakes to the east coast and across the Four Corners region. However, for April, you start to see winter try to make a last stand, if you will, and some below normal temperatures across most of central and western Canada, across the northwest and north central part of the country, above normal temperatures, south central, and basically centered on the southern Rockies. April does look a lot less active, though, from the analogs. Very, very dry near the Gulf Coast and across most of the south, and above normal precipitation pretty much restricted to northern New England and upper Great Lakes, and maybe the interior part of the Pacific Northwest. For May, spring well ahead and almost looks like a preview of summer here. You see a lot of above normal temperatures across most of the country, especially the central part of the country. And precipitation gets a little more active along the east coast and probably the Great Lakes. However, dry pattern shown on the analogs across most of the plains, down towards the western Gulf Coast area and out into the west, which isn't good for drought prospects. So wrapping this up, February through April, the East Coast and the South should have above normal temperatures through the 3-month season. The analog suggests below normal temperatures across the north central part of the country, the western half of Canada, and the western part of the U.S. For precipitation, active from the Arklatex region up to the Great Lakes, with below normal precipitation across the Four Corners region, central and southern Texas, along the Gulf Coast, and along the immediate East Coast. And our top 6 snowfall departure analogs shown in order of importance. Well, you can see here, there's a couple of exceptions where the Northeast is a little bit less than normal, but there's a lot of these do show some enhanced snowfall across the northern part of the country, and there's a few of them that do show some snow getting into the south, and that makes sense. We've seen some of that so far, and I don't think we're done seeing that as we get into the end of January into February. So let's go forth on these sub-seasonal factors that we talked about earlier and see if we can shed some light on them. And these are some weekly to even monthly pattern variations, some of which are more difficult to predict. The polar vortex, we talked a little bit about that. The strongest influence is in the cold season, and we are still there, so the polar vortex can have a significant influence. Also, tropical thunderstorm clusters in the tropics, referred to as the Madden-Julian oscillation, or the MJO. And depending upon the strength and location of these clusters, they can change the pattern. So you get some north and south jet stream fluctuations. You can even get some blocked and stalled out jet stream patterns as a result. And they typically last a week or two, sometimes even longer, depending upon how fast it moves. And then snow cover or soil moisture. So if you have a bunch of snow on the ground, it typically promotes colder temperatures in general. Soil moisture matters too. If you have dry soil, you'll have some warmer days and some cooler nights, so higher spread between your highs and lows. And if you have wet soil, it's typically a little bit cooler during the day, as more of the sun's sun's energy has to go towards evaporating moisture than if there were dry soil. It will keep the temperatures up a little bit at night, though, when you have wet soil. Let's talk a little bit about the polar vortex here. And a strong polar vortex is more circular, which is what you see in the image on the left. You can see a nice circular, strong vortex. It keeps the coldest air bottled up at the highest latitudes. And there's a nice jet stream across the polar region that just keeps it all nice and bottled up. And a weak polar vortex, on the other hand, means it can be broken up into several smaller features, and each little feature there can have some pretty cold air in it. And blocking ridge patterns can help determine where these pools can locate. So you have more of a wavy jet stream pattern when you have a weaker polar vortex. Prediction time can be limited to under 2 weeks in terms of the specifics of what this could do to a certain region. What we'll try to do is see what the polar vortex will be up to using our analogs. And here are each individual month, February, March, and April, from left to right. And what you can see here is a polar vortex for February and up across Canada, basically across Hudson Bay, it's not too much displaced from the pole, maybe a little bit. And then March, you see that more or less get pushed off to the west. So there's a little bit more in the way of those yellow colors near the pole in March. But the analog say that in the cooler air as a result of that will be more or less across Western Canada or portions of Northern Europe. So that just because you have the polar vortex moving around doesn't mean it's going to be in certain parts of the country. That means that it's going to go somewhere. And then April, polar vortex, a lot of blues near the poles, so it still doesn't look too disturbed, but you do see it kind of cracking up a little bit across Canada and then maybe across portions of Europe. So it'll be on the move a little bit, but overall it's pretty strong. So let's talk about the MJO a little bit here. And how we like to keep track of that is looking for areas of upward motion in the atmosphere. That's what those thunderstorm clusters like to be. So over there on that forecast and observed chart here on the left-hand side of the screen, you see all those blues across the Pacific Ocean centered around the date line here from basically now until the first week of February. That's where those thunderstorm clusters are expected to be. And looking here at the temperature analogs, you can see those blues from phase 8, which is, those clusters are centered on phase 8. You can see that on the map, MJO phase map below. When you have the MJO in that position, you typically get cooler than normal temperatures, and that's what we're getting, and that's what we're going to get through the rest of January and perhaps into the first week of February. However, looking forward here past the 8th of February, and especially as we get into the end of the month, you see the MJO will abandon that position and will move around the globe, and eventually it'll come around to the Indian Ocean and into the maritime continent region. So that'll be a brand new pattern. So what that's going to do is change the pattern almost back to what we had in December, where you see warmer than normal temperatures, all those oranges on the right for that phase 4 for February, especially the middle part. And that's going to be a lot different than what we're experiencing right now. So analog suggests a much warmer pattern will take over for middle February and probably beyond. And our storm track should shift from where it is now, basically along the East Coast, to the more or less the Midwest and along the West Coast again. So that we're gonna have a significant change, and we're expecting by the time we get to the middle part of February as a result of the MJO. Well, one thing that happened here, which sometimes can have an impact on the weather for the months ahead, a volcanic eruption in the wrong spot. In this particular volcano, it's a Tonga Hunga Ha'apai volcano, and we have some stats that resulted from that. Now, this eruption here was mostly a gigantic steam explosion. It was created by the rapid exposure of the magma chamber to the seawater. As over half of the island collapsed into the ocean, and that created the tsunami that you heard about in the news. About 95% of the island where this volcano is now gone. And this volcano is located about a couple thousand miles east of Australia, but still close enough to the tropics where there can be an issue. It was extremely powerful, but it was also a short duration event. And sulfur dioxide emissions, which can cool the climate if there's enough of it and it gets blasted high enough into the atmosphere, it was around 400,000 metric tons, which is a lot. But if you want to compare that to the 15 million metric tons that occurred with Mount Pinatubo in 1991, that was only about 3% as large. So it's not going to have a large impact as a result. So the net global cooling from this eruption might only be 1/100 of a degree Celsius, or really too small to measure effectively. A couple places it could be a little locally higher. But if there are additional eruptions and we get more sulfur dioxide up into the upper atmosphere, then there could be more large eruptions, but we do not expect any significant impacts to our climate system from this volcanic eruption. So let's fast forward here to the seasonal weather models. See how that compares to our analogs. Here is the CFS V2 model from February through April. On the left, you have temperatures. On the right, you have precipitation. And for February, we do have above normal temperatures across the southern part of the U.S. It is predicting below normal temperatures across the northeast and north central part of the country, especially the north central. And for precipitation, it looks a lot like the analogs, with the northwest and the Midwest through the northeast covered with the green, and the far southern reaches showing below normal precipitation. However, for March, similar to the analogs, it shows the cold backing off into the northwest US and western Canada, with above normal temperatures across most of the central and eastern part of the country. The south central is most favored. Precipitation above normal across the northwestern part of the country and western Canada, but below normal across the southern part of the US, especially South Texas near the Gulf Coast, and then active from the Ohio Valley, Great Lakes eastward through parts of New England and the northern mid-Atlantic. For April, you can kind of see the weakness in there that develops. It's not too dissimilar to the analogs. Near below normal across the Ohio Valley Midwest, and above normal in the Southwest, centered on the Four Corners region in western Texas. And precipitation a little bit quieter, except for the Great Lakes and Ohio Valley, where it is a little more active. Let's compare that to the NMME model, which is a North American Multi-Model Ensemble, which is a bunch of models run from centers in North America. It can give us some ideas here. Now, this model typically tends to run a little too hot in terms of temperature. But some of the trends here can tell you certain things. And focusing on temperature from February, March, and April, you start to see some things that emerge. First, in February, it does show the warmest air across the east and south. That's similar to the analogs and most of the guidance, with the coolest air across the northwest and western Canada. So that's consistent. But for March here, you see more widespread warm anomalies across the central and east with that cooler air backing off. That's also similar. But for April, you can see the warmth backing off across the northern US into the northeast, with warmth more or less centered across the south central part of the country. So, I mean, that is relatively consistent. So the trends aren't bad. It's just probably a little bit too warm. On the precipitation side, it does show above normal precipitation with those greens across the northwest and then across the Ohio Valley into the northeast. That's consistent. And then for March, it does show pretty much the same thing. And then April, a little bit quieter, especially across the plains and the southeast. But it also shows, like the CFS does show a little bit more precipitation maybe lingering across the Ohio Valley and then into the Appalachians. And comparing that to the ECMWF model, and well, the trends are going to be virtually identical. February, warmth in the east and the south, coolness in the northwest and western Canada. For March, more widespread above normal temperatures for the central and east, especially the south central, then cool in the northwest and western Canada. And then for April, you see less warmth across the northern tier, more warmth located in the south central and southwest. So the trends are pretty good. Precipitation, very similar to the NMME model, February and March, with the most active conditions across the northwest and across the Ohio Valley through the northeast, with the drier conditions across Texas all the way through the southeast. So that's consistent. And then for April, it does show that more active weather pattern from the Ohio Valley and into the Great Lakes, and less active across Texas through the southeast. So the trends are pretty stable. It's, sometimes you have differing trends, but most of the stuff is showing us the same thing, which is nice. So with all that, I'm going to send this over to our VP of Extended Services, Steve Strum, and he's going to close this out for us and tell us what all this means for you and present the final forecast. Please take it away, Steve.
Thanks, Nate, and thanks, Jeff, for taking us through all the historical weather we've seen the last few months, as well as all the forecast inputs to our forecast. Now let's go ahead and take a look at combining all of that into our final forecast. Now, first off, we'll kind of just look at the near term here. As Nate mentioned, we have a cold pattern in place across the eastern U.S. The MJO favors that continuing really for the next 2 or 3 weeks. And then, likely we'll see a change take place after that. But in the meantime, certainly favoring a lot of widespread cold across the eastern half of the country right on through the start of February. On the right-hand side there, you can see from the ECMWF model, the forecast snowfall for the next 9 days or so, taking us through pretty much most of the balance of January. And certainly, again, you can see across the parts of the East Coast, Midwest, and Rockies and Western Plains, some potential areas for additional snowfall here coming up before the end of next week. Now, looking at the month-by-month forecast, again, we have what we're seeing right now in January is a cold eastern half of the country. However, as we transition through February, as Nate mentioned with the MJO shifting, that will lead to a warming trend across the eastern U.S. as February progresses. We may, though, still start out colder than normal across that area, but then just trend progressively warmer as the month moves along. And obviously the key is going to be, how fast that transition takes place and exactly when it does. If the cold lingers an extra week, the month may end up averaging closer to normal. If it, moves out just a little bit faster, we could see stronger warm anomalies along the East Coast. But the bottom line there is a cold start and a warm end to the month on the East Coast. And the West Coast, kind of the flip, with a warmer start and a colder second half of the month for most of that region. The warmth should expand, though, as we progress through March. So more of the central and eastern U.S. trending warmer, kind of more like what we saw during the month of December. But there is a potential, though, that we could see a return of the colder pattern again, at least for a time during the month of April. And so we may still see some lingering winter weather conditions across the upper Midwest as we progress into the April time period before we kind of really get into that full spring mode by May. As we look at our 3-month average, everything should more or less balance out to a colder than average northwestern half of the country and a warmer southeastern half of the country. The probabilities of the warmth are fairly high across the eastern U.S. Again, the only real caveat there is how fast that warmer trend develops during the month of February, and that will kind of play a little bit of a role as well in that February, but also the 3-month average. But generally speaking, except for that potential start of the month of February with a cold air in the east, most of the pattern thereafter looks to be generally favoring a warmer regime for that area. In terms of HDDs, this winter is going to likely end up warmer than average overall, about 5% warmer than average for both the December to February and November to March period. Possibly, if we do see more extreme cold during February than what's currently expected, that could take us to only being about 2% warmer than normal. Now, that is going to end up being warmer than last winter for December to February, but likely will end up about the same or a little bit colder than last winter for the entire November to March period based on the current expectations. Looking at this in chart form, you can see again, we've been trending a little bit colder the last couple of winters, and this winter should edge out last winter for the November to March period overall. Part of that was just because we had a very warm November and March last winter, and so this winter, those months comparatively were cooler. So even though we haven't had the extreme cold that we saw last winter during February thus far, the overall November to March period could end up a little bit colder overall, but still likely coming in, in that top 10 warmest winters as it stands right now. Again, on the bottom there, you can see your month-by-month breakdown of what the HDs are currently forecast to be. So generally speaking, after this colder January, by and large, we should be looking at fewer HDDs than normal because of the East Coast being in that warmer regime where the higher population centers are. And even though we may have a lot of widespread cold from the plains westward as we head through the middle and latter part of February and be into March as well, the lower population areas in there won't contribute as much to the HDD totals for the country as a whole. Now, looking at our risk, certainly if we do see the cold fade a little bit faster and the warmth in March is a little bit stronger than currently expected, we could see much of the central and eastern U.S. average warmer than normal for the entire February to April period. Conversely, if the cold does linger a little bit longer, we could see the northeast and our cold scenarios average a little bit closer to normal for that February to April period. Again, the highest risk for cold on the eastern U.S. is February, in case the cold does perhaps linger a week or two longer than expected, but by and large, the overall confidence in the warmer trend in that area is fairly high. It's just really a question of how fast it develops during the month of February. Looking at precipitation month by month here, again, as we kind of saw in the analog maps that Nate showed in the model guidance, for the most part favoring a fairly wet regime across the middle part of the country from the eastern plains across the Midwest and Great Lakes area. Obviously, as we continue the cold air here in the near term, that will translate to above average snowfall. As we progress more towards April, that may translate to more just heavier rains and maybe some severe weather events as we head through latter March and into April. But by and large, you can see the overall trend across the southwestern part of the country is, for the most part, drier than average. You may see some heavier precip sneak down into central northern California at times during February and March, but for the most part, most of the Southwest, Southern Plains region does look to be drier than average, continuing the trend we've seen there so far this winter season. And again, for the 3-month average, that looks to be the focus for the driest weather. And we have had drought expanding across those areas as well. So likely we will be entering the spring season with drought already in place across the south central and southwestern portions of the country. Looking at the snowfall, most of the northern tier of the country should be seeing above average snowfall for the winter season as a whole. The southern half of the country is always trickier because normals are very low. In many cases, once you get across that southern third of the country, your average snowfall is under 10 inches. And so really, if you get one snowstorm, you can be above normal. If you don't get a snowstorm, you're below normal. So it's kind of binary. And so likely we'll have some areas that do average above average or higher than average in snowfall across the south if we do get a couple of these storms that continue to sneak down into that area in the coming weeks. Now, looking at the drought that I mentioned a bit earlier, again, already drought conditions in place across most of the western half of the country. The heavier precip we saw along the west coast during portions of December with some of those big snowfalls in the Sierra have reduced the severity of the drought somewhat from what it was heading into the winter season, but it is still in place, just not quite as severe. And again, across the southern half of the Plains and Rockies, where we likely will see dry conditions persist for the balance of the winter season. The drought that's already there will just continue to likely get worse as we head towards the spring season. And that will also continue to be a threat for continued fire risks for those areas anytime we do see a warm and windy pattern across that area. And indeed, that does look to be the highest fire risk area is across that part of the country, as well as along parts of the coastal areas of the southern half of the East Coast. Many of these areas here have a higher fire risk during late winter and early spring when grasses and other vegetation are still dormant and they can burn much easier. You don't always have to have conditions as dry at this time of the year because until things start greening up and getting pulling up more moisture from the soil, you can even have some wet conditions take place, but the vegetation is still dry and you can still burn them quite easily. So the combination of the dormant vegetation and a dry pattern that we're seeing in those areas likely will enhance the fire risk as we head through the next several months. Looking at flood risks, for the most part, we are not looking to have a lot of severe spring flooding at the present time for most areas. There are some areas that do have some risk for moderate flooding across portions of the Midwest and the Southeast, but overall, at the time currently, we're not looking to have a very high risk for widespread flooding on, say, the Mississippi River presently, just because we haven't had so far at least a deep snowpack buildup across the central U.S. that would then potentially melt and produce a higher flood risk. But obviously that could change between now and April. So we'll be watching this very closely. And if we do see a lot of large snowfalls during the next couple of months across the upper Midwest, that could enhance the risk for flooding this spring. This map will change a lot and those flood risks will certainly increase. So kind of summarizing things here, again, across the western U.S., the southern half of the West, for the most part, staying warmer and drier than average for the remainder of the winter season into early spring. But the Northwest likely will trend colder and snowier again as we head through February into March. The north central U.S., again, seeing a fairly high probability of cold through February, may trend warmer thereafter, but certainly for the remainder of the heart of this winter season, additional cold and snow risks for those areas. The Northeast staying cold and snowy likely into the first part of February, but then trending warmer as we head through the second half of February. And as that East Coast trends warmer, we should see the storm track gradually shift westward. And so many areas in the middle part of the country will have a higher chance for above average precipitation during the remainder of the winter season. And as we transition towards March, especially in April, that storm track will likely favor an increased severe weather risk across portions of the south central U.S. and up towards the Ohio Valley as well. Now, looking farther north across Canada to kind of give you a better idea of what we're expecting across those areas. Again, most of central and western Canada averaging colder than normal, not just during February, but likely all 3 months. You can see on the monthly maps on the right-hand side, we are expecting those areas to stay consistently colder than normal right on through the middle part of the spring season, while southeastern Canada, for the most part, averages warmer than normal once we get out of this cold pair that we're currently in. So again, most of Quebec and Ontario will likely stay cold through the early part of February, but then thereafter likely seeing a trend towards more warmth as we progress through the second half of February and into March. Again, the The higher precip totals across the southwestern portions of Canada will, of course, lead to higher than average snowfall across most of those areas as well. Now, looking globally, we are forecasting most of Europe and Asia to come in warmer than normal during February through April, although it will not be continuously warmer than normal during that 3-month time period. Likely we will see in most areas at least a period of seasonal, or if not, somewhat colder weather at some point during the next 3 months. But overall, the trend does look to be fairly warm as we head into the first half of the spring season, and precipitation potentially coming in somewhat higher than average as well across portions of Central and Northern Europe, and as well as parts of eastern areas of Russia and really all of Eastern Asia in general. Looking across the Southern Hemisphere as they wrap up their summer and go into the fall season, potentially quite wet across Eastern Australia and portions of eastern areas of Brazil as well. Now, looking briefly here at the renewable energy outlook, we are forecasting with this pattern to be windier than normal across most of the plains and Rockies, especially the southern half of the plains, as well as the Rockies as we head through the next few months. And so that will likely lead to higher than average wind generation production across ERCOT and at least the southern half of SPP. And so those areas likely will be benefiting from this pattern in terms of higher winds. Again, the higher winds, though, will also combine with the dry conditions to produce a higher than average fire risk for those areas as well. So we may be dealing with some wildfires, continuing the next few months that could potentially threaten power lines and that kind of thing as well as we progress forward into the spring season. For the most part, the storm track across the northern tier of the country will keep those areas on average cloudier than normal, while at the southern part of the country should for the most part stay sunnier than average. So kind of summarizing things here, for the most part, the analog forecasts do suggest an active end to the winter season. The current storm track along the East Coast may persist there for a couple more weeks, but we should see that retract westward more towards the middle part of the country, kind of from the northern parts of California across the Central Plains up towards the Great Lakes area. And so that will be likely the key focal area for the active weather as we progress into the middle and latter half of February, as well as into March. The cold risks with that storm track shift will also shift from the eastern U.S. back towards the north central and then eventually the northwestern U.S. as we progress through February, and likely being kind of confined mostly to the northwestern U.S. and western Canada by the time we get to March. For the most part, above normal temperatures should become more frequent across the southern and southeastern U.S. during February, and then likely all of the eastern coastal areas likely trending warmer than average for the second half of February into March. With the current expected storm track, we should see above average snowfall for most of the northern third or so of the U.S. for the balance of the winter season. Again, across the Northeast, that higher snowfall will come during the next few weeks and then less snowfall thereafter. The upper Midwest will likely see an increase in snowfall as we progress into February and through the month, as it kind of ramps down a little bit along the East Coast. And with that westward shift in the pattern, that will once again increase the risk for severe weather across the southern half of the eastern U.S. during February, and then expanding northward as we progress into the spring season. In terms of energy impacts, again, the Arctic air that we have at times in place across the eastern U.S. will continue into early February, keeping strong heating demand across those areas for the next few weeks. And then that will again shift westward, lessening the impacts on the East Coast, but increasing them across the north central and northwestern U.S. And then certainly as the warmth expands across the south, that will lead to an earlier than average end to heating demand across the southern tier of the country as we progress into later February and March. But it likely will also lead to an early start to the severe weather season. And so that could produce some local issues on the energy side as we head throughout the spring season. In terms of transportation impacts, obviously the higher snowfall forecast across the northern half of the country will of course impact roadways and transport in general as we progress through the balance of the winter season. The warm lake effect, or the warm lake waters combined with the lower than average ice cover will also enhance any lake effect events anytime we do have a cold outbreak across those Great Lakes. And again, as we progress through the February and March period and the storm track does shift westward, we will be looking at heavier rainfall potentially across the Tennessee and Ohio valleys, with increased flooding risk for those areas during any heavier rainfall events as this pattern does gradually shift westward. Now, looking at public safety, the severe weather season obviously will be a primary focus as we head into the spring season. And so we are looking again to see an above average severe weather season this year, assuming the La Nina does persist as we're currently expecting. If we do see a fast end to La Nina like we saw last year, the severe weather season may end up closer to average like it did last year. But if we do see the La Nina linger through spring, as is what is currently forecast, then we should see an overall above average level of severe weather activity during the March through May period. Snowfall will still be a problem as well, obviously, as we head into the early part of the spring season across especially the Great Lakes and the upper Midwest back towards the Northwest. And certainly if we do continue this heavy rainfall pattern into March and April across the Ohio Valley, we will have to watch those areas for a gradual increase in flood risk. Looking at aviation impacts, the active pattern across the northern U.S. will result in stronger than average jet stream winds across those areas, weaker winds aloft generally across the southern tier of the country, so that will certainly impact flight plans and overall flight times. The storm systems will also, of course, produce more frequent IFR conditions. You're going to have more issues with airports having to deal with snow removal on runways, causing delays and that sort of thing as well. The severe weather season also will likely result in the aviation industry having to take more proactive approaches to managing assets and personnel as well in a timely manner than maybe would otherwise normally be the case during this upcoming spring season. And so that's pretty much a look at the forecast. At this point, we can open things up to question. Again, in summary, the overall trend looks to be for the eastern U.S. to generally trend warmer after the first week of February, the western U.S. generally trending colder after the start of February, and the middle part of the country trending more active in terms of storminess as we progress through the latter part of the winter season. And the northern U.S., again, being the focal areas for the heavier snowfalls, especially as we head through the month of February. And so with that, I'll open things up to questions. And Nate, what do you see so far that's come in?
Well, I have some questions that have come in here. So we'll start with the first one here. Can you explain what ENSO is? And Jeff, do you think you could take that one?
Sure. ENSO is an acronym, stands for El Nino Southern Oscillation. And essentially, it's the variability of the temperature pattern along the equator in the Pacific Ocean. And sometimes that water tends to heat up along the equator. And when it gets above normal, it becomes an El Nino. If it tends to be the opposite, where it's colder than average water along the equator, that would be a La Nina. And essentially what happens is you have a change in where thunderstorms and rainfall tend to occur. In the warmer El Nino pattern, you get a lot more thunderstorm activity in the eastern half of the Pacific Ocean. During La Nina, like we have right now, it's reduced rainfall and thunderstorm activity in the eastern part. And then the net effect then for the United States really has to do with the way the jet stream changes across the Pacific Ocean. During an El Nino, we have a more active southern jet stream that flows from the Pacific across the southern U.S. But with the colder La Nina pattern, we tend to see the jet stream be further to the north. So that's mainly why we look at that as a leading indicator for the upcoming seasons, is just how that influence, whether it's El Nino or La Nina, shifts the position of the main jet stream track. So hopefully that was a lot of things going on there, but hopefully gives you some idea of why we look at that ENSO pattern.
Awesome, thank you, Jeff. Got a couple other questions that are dealing with pretty much the same topic. And can we comment a little bit more on the developing drought conditions across the South and in the South Central part of the country? And maybe expand a little bit about what that means with the dry temperatures, the soil moisture, and what drought conditions could look like as we go into May. And then maybe comment on something as we go into the summer. So I could probably take that one. For the South Central part of the country, it has been dry and it will be dry. So drought conditions should probably be relatively extreme as we head into the upcoming spring season. Now, if we don't get as much in the way of thunderstorm activity or rainfall that occurs across the southern plains as we expect that we don't, we think most of the activity will be more or less to the north and east of that region, then we could be signing up for a pretty severe type of drought going into the summertime. Will it be 2006 or even 2011? Now those are two relatively extreme cases. They have the possibility to be almost as bad as that. But at this point, it's difficult to to assume we're going to have that bad of a situation. But the worst situation we think we're going to have is going to be across Texas, maybe up in Oklahoma, and up into from Colorado through New Mexico. Those places like that, probably under the worst conditions right now. But I do think, as we go further east along the Gulf Coast, as we have the precipitation reducing from what is occurring now, and then going in through the spring, could have some sneaky drought conditions that occur across the Gulf Coast states and into the southeast coast as well. Probably won't be half as extreme as what occurs in Texas, though, and into the southern Rockies. And as far as when this could relieve, sometimes when you get situations like this drought will go on and on and on, and then all of a sudden, a switch will flip, and you won't have that anymore. So maybe once we get rid of the La Nina conditions this summer, and if we get any sort of warmth or anything that approaches an El Nino, which is possible by the time we get into the fall, if that happens, then that'll be a better chance of getting more precipitation into that region, and we can start showing some relief on the drought conditions. But a lot of times when you're dealing with droughts like this, you tend to get a flip, and once it starts becoming better, it becomes better in a hurry. So we'll just have to wait for that point to go. But I don't think it's going to happen before the end of this summer. And let's see here. Looking at other questions that have come in. And let's go with this one first. And Steve, if you could comment on it, do you think the sunspot cycle played or will play any role in the upcoming, the rest of this winter season into the spring?
So yeah, obviously one thing that's been interesting this winter, well, the past year or so, is that the solar cycle has been ramping up much faster than what was initially forecast, and so we're basically running almost a full year ahead of what the forecasts were on our current level of solar activity. And broadly speaking, when we have an increase in solar activity, that there's not much change in terms of visible light, but there is generally a higher percentage change in the amount of UV light that's emitted by the sun during a more active solar period. And because of the ozone layer in the stratosphere, there's a higher absorption of UV light at that level. And so you do tend to see a noticeable warming in the stratosphere over the tropical latitudes where there's more sunlight. When the sun becomes more active, it does result in an expansion of the atmosphere, impacts satellites and everything else. But it also increases the temperature gradient in the stratosphere from the North Pole to the equator. And that can potentially result in a pattern that would tend to strengthen the polar vortex. And we have seen a stronger than average polar vortex all winter season. So it's possible that has played a role in the stronger polar vortex that we've seen so far this winter season. We're of course running or ramping up towards solar maximum, which will likely be in 2024. Of course, maybe it'll be earlier given the faster ramp up, but we'll be in that increasing trend the next couple of years as solar activity increases. So that trend will not certainly change. Now, it doesn't tend to have much impact on the summer pattern as much, but you tend to see it mostly in terms of the the polar vortex impacts during the winter season. So it's possible that has been part of the reason why we have seen the extremely strong polar vortex this winter season, which, and the strong polar vortex again is resulted in the cold air being confined, more towards northern latitudes, and we've had less ability to get the stronger cold southward as a result of that stronger polar vortex. So likely some impact, but again, at this point, it's kind of hard to actually say what the net impact was of the stronger than forecast solar cycle.
Oh, thank you very much, Steve. Great points. think we have time for at least one or two more here. How about this one, Jeff? Will La Nina hang around long enough to impact the upcoming tropical season?
Well, it likely is going to diminish by late this spring, and we're currently expecting a neutral ENSO condition for the summer and fall season. Um, that being said, though, we typically do see more enhanced tropical activity than average in both La Nina and neutral ENSO situations. So the risks based on uh, on a neutral condition are still indicating an above average season for the Atlantic. We're also looking at above average temperatures in the Gulf and Atlantic Ocean for this summer and fall. So both of those combined together would lead us to at least initially believe that we are going to see another above average Atlantic tropical season. And we've also started looking at a little bit of the upper air pattern for the summer and fall season, and it looks pretty similar to last year in terms of the potential track risk. So the Gulf Coast would be in a position to see above average tracks, as well as the upper part of the East Coast. So the Northeast, once again, seeing an enhanced threat. So even though we are going to be in an ENSO neutral rather than a La Nina, we think 2022, early indications are it's going to be another active season, potentially active for the U.S. landfalls as well.
Oh, great points, and thank you very much, Jeff. We'll do one last one here. I think we'll be out of time. We're already past top of the hour, but a lot of information here today, and we want to get in as many questions as we can. That's a question coming about summer conditions here. What will that be like? And will there be a lot of heat and humidity around? So I'll take that one. As far as the summer here, the first look at it, we talked a little bit already about this drought conditions in the south central part of the country, and usually where you have that occur, the hottest temperatures tend to follow. And from the south central part of the country, from the southern plains over to Colorado, New Mexico, maybe even southern Kansas, that's probably where the warmest temperatures overall are going to be this summer. There'll be some probably episodes of significant heat. Things can change. We're still only in January, but from the way we're looking right now, from all the analogs and model guidance, that's going to be the area that we'll be interested in the most for heat. The second most area to watch out for is probably going to be the northern plains into the central and northern Rockies, probably to a lesser degree. Might take a little bit longer for things to dry out as much as up there as much as they would be in the south, and there's somewhat more question as to how dry will actually be. But if it turns out to be as dry as we think it is, then the heat will develop there as well. So especially for July and August, the northwestern part of the country and into the northern plains will be, well, the heat will kick up. However, if you look toward the east, probably from the Mississippi Valley eastward, we're not expecting it to be quite as hot. June, July, and August may be near to slightly above normal. A lot of the summers have averaged above normal recently, more or less expecting that to continue, but we don't expect that the temperature anomalies will be all that significant across the eastern part of the country this year. And part of that is because we're expecting more active precipitation across those regions. So from June, July, and August, especially closer to the East Coast, above normal precipitation. So that'll keep a lid on temperatures. And given all the warm water we're expecting in the Gulf and the Atlantic here, that part of that can get some humidity going here too. So I'm expecting muggy conditions, even though temperatures won't be all that warm. Humidity levels across the eastern part of the country will probably be higher than normal. That's a general sense of what we're expecting this summer overall. And I think that's all. I think that'll do it for all the questions that have come in. I'm going to pass it back to Andrea for closing remarks.
Thank you, and thank everybody for joining us today. We will be sending out a link to the recording of this presentation and our mid-season update infographic that kind of summarizes what is going on within the next few days. So thank you and have a great rest of your day.